Thank you for coming out to the Emergent Works. Oh, Emergent Works is first workshop in the summer season. So we do look forward to having a lot more coming up. So quick overview of today. We have a workshop called Git Good, a crash course in Git, which is being curated by Cate. He is a software engineer for a very large tech company, but he is also, and most importantly, a current EW mentor in the one-on-one virtual mentorship. So that alone, let's give it up for Perry. Woo! Yes. So without any further ado, once again, thank you for coming out, and let's get to the presentation.
All right. So thank you for the intro, Eli. It says Army enter the waiting room. I guess I'll admit him.
Oh, yep.
So anyways, can everybody see my screen? Sweet.
Yeah, you look good.
Awesome. I will not pretend to be some expert with Zoom. So when things go wrong, please be sure to let me know. So yeah, this is a talk on the basics of Git. Hi, I'm Perry, and thank you again, Eli, for the intro. The about me, I guess, is superfluous at this point. I'm a software developer. I like singing and improv, and I live code. So if you like this, twitch.tv/gravitydd. I'll stream while I'm working on various projects and things like that. So what is Git? What is this thing that I am teaching today? Well, if you were to Google Git, or what is Git, you would probably find the official website that will tell you Git is a free and open source distributed version control system designed to handle everything from large to small projects with speed and efficiency. As for what it actually is, so the creator, Linus Torvalds, had some choice words for it. It's a random 3-letter combination of letters that is pronounceable and not used by any other commands and tools. It's synonym for stupid. When it works, everything is perfect, and it is the global information tracker. And when it doesn't work, he had some other words for it. Again, this is just the creator. I'm not making this up. But actually, what does it do? So Git is a tool that manages your code. It tracks the changes to your code over time, and it enables some really key features like collaboration and things like that. Basically, if you are working in software, you are basically guaranteed to be using either Git or something like it. You need some way of keeping track of the changes to your code. So a couple of misconceptions about Git. Git is not an online service. There is a thing called GitHub that is oftentimes confused with Git, and I think that's by design on their part. But Git itself is just a tool that is on your computer, and it's not a way to discover other projects, and it's not really backup software either. By default, everything is on your computer when you're using Git, and if your computer goes out the window, then you still don't have any backups. Now, if you combine Git with other services like GitHub and these other websites and stuff, then it can start to resemble these things. But Git itself is just a single tool that lives on your computer. So, hang on, how do I use a computer? All right, oops, technology is difficult. All right, so why do we actually want to use Git? So if you have worked on a project without version control before, then this may look familiar to you. You know, you have some file, some code or whatever, and you want to make some changes, but also keep a copy of the old one just in case you mess things up. Okay, so we have some code new, and then we make a change to that. So some code new.cpp.new, and then eventually you get down to some code v2_old.new. This mess, and this is all just one file, just different versions of it. And this is what Git helps to prevent. So Git is great. So Git is often talked about in a multi-developer context. It is good for if you're collaborating with people and things like that. But what we're going to talk about today is why Git is great for single developer use. Even if it's just you working on your passion project or something like that, it is great just for restoring deleted code and files and making it so that any change you make to your code, you can undo it, which is really nice. If you ever had that feeling of, I had this code working 5 minutes ago, what happened? Git is designed to prevent that situation, or at least to answer that question. So any questions about what Git is or why we might want to use it? I'll take that as a no, but I believe that Eli is going to be monitoring chat for any questions, and we will have plenty of breaks for questions and such if anybody does have any questions that occur.
Absolutely, absolutely. So guys, at these stop points, feel free to chime in. If not, we'll be taking more questions at the end of each other segment and then a bigger Q&A at the end. All right, so if there are no questions, Kerry, take it away.
All right. So let's start with everything you need to know. Simple as that. So here is how to use Git. So if you're on, Git has a couple of different ways to use it. Various companies like GitHub will make graphical interfaces for it, but the default and the universal way of using Git is on the command line. So if you are familiar with the terminal, you can open one up and just cd into whatever project that you are working with. And if you are not familiar with the terminal, then feel free to ask questions or ask your mentor or something like that. So, and the nice thing about it is that it's basically the same process whether you're on Mac or Linux or Windows. If you're on Windows, when you install Git, there'll be this thing called Git Bash that you can then open and use it as a terminal, and all the commands will be the same. So one more thing, let's get a little bit of terminology out of the way. So in Git, there's the concept of the repository, also known as the repo. And this is just your folder with all your code in it. And so it's the project. And the repository in Git terminology is specifically like the set of files that Git cares about. So it says, this is your project. And commit, or a commit, is a snapshot of your code at some point in time. So what Git does is it will let you commit anytime that you want to take a snapshot of your code, which should be very often, and then track your changes between every commit. So, what did my code look like, last week, yesterday, 6 months ago, 6 years ago? You can see all of these commits. So your project exists in a repository, or usually called a repo, and it has commits. So let's talk about actually setting up a Git repository, right? So I have some code here. So I have a project, so cd, what do I call it? My project, I think. Yeah, and it's just got this one file, a website I'm building that says, hello, Emergent Works. And the nice thing about Git is Git doesn't care what language you're using, or if it's JavaScript versus HTML or anything like that. All Git cares about is that there are files with text in it. And this is really nice. It doesn't matter what language you're using. I'm using HTML, but it doesn't matter. So the first thing we need to do is set up our repository, because right now this is the files are there, the files exist, but Git hasn't been told to care about them. So, I was setting up for a joke. So yeah, pay close attention here. It's very complicated. Just kidding. All you need to do is run Git Init. So if I do Git Init, bam, this project is now a Git repo. So that's it. And wait a minute. Hold on a moment. I thought I deleted all my. All right, we're good. All right. Anyways, technology is hard. Don't mind me. So let's talk about the Universal Git Workflow. So this is the series of steps that you're working through as you're working on a project and how you interact with Git. Oops. So the first one is modifying the code and add files and so forth. So let me introduce perhaps what I think is the most important command in Git, and that is Git Status. Git Status is basically saying, hey, tell me the state of the world. What does my repository look like? So if I do Git Status, let me zoom in a little bit. So it will tell me what branch I'm on. What that means, we'll get into in a minute or 30 minutes. It'll say, okay, what commits are there? Well, I don't have any commits. I just initialized this. And untracked files. So let's talk about, oh yeah, so here are the things that Git Status shows you. I use Git Status constantly to sort of get my bearings and say, you know, what does my code look like? What files does Git care about? What files have I changed recently? Things like that. So let's introduce a few more terms. So tracked files are the files that Git knows about. That means they're present in any of your past commits. And the rule of thumb is if there's a file that you care about or that you think that you are ever going to change, you should track it now. And staged files are the files that will be added in the next commit. So right now, this file index.html existed before I initialized the repo. It's in the folder here, but Git hasn't been told to care about it. It's not tracked. So how do we, oh wait, hold on. Where are we? Okay. Oh yeah. So before we move on, I'm like, wait, where am I? What does this thing do? All right. So yeah, so that's tracked files and staged files. So right now we can see that my project has one untracked file. And how do we add that? We'll get into that in a minute. But first, any questions? All right, I'll take that as a no. Also, just so I can get a feel. So how's the pacing, everyone? Am I going too fast, too slow? Any impressions? Any thumbs up in the chat? If I'm dragging on too slow or going too quickly, please let me know and I'll adjust accordingly. So far, so good. All right. Thank you, Cate.
Brandon says good. Isaiah is good.
Excellent.
All right.
Good stuff. All right. So right. Let's mark files ready to commit. Right. So what do I mean by that? So like I said, right now we have this index file, but it's not tracked. So we want to tell Git, hey, I'm going to commit this. I want to start caring about it. Also, Eli, are you adding people or admitting people from the waiting room, or should I be doing that?
Yes. Can you please press admit for them? I think because I shared the host permission, it's not allowing me to do it.
Got it. No worries. I can do that.
Thanks
so yeah. So how do we do that? So that is Git Add. So add says, hey, Git, I did something to this file, or this is a new file that I want you to care about. And we just say Git Add and then the name of the file. So if it's a new file, it adds it to the repository. If the file already exists in the repository, it will tell Git, hey, I want you to make a note of the changes that happen in here. So let's do that. And now if we do Git Status, we can say, hey, this is a change to be committed. Note that it hasn't been committed yet. There's still no commits, but it is a change that will be committed. Do you have a question, Eli?
Oh, no, we're good.
Oh, okay. So how do we actually commit them though? So in Git, note that this is separate, marking something to be committed and then actually committing it. So when it's in between after we do Git Add, that means it's staged, it's ready to be committed. The reason being, you don't always want to commit everything in your project at once. Maybe we only want to make a note of some changes and other things are experimental and we're not ready for it. That's the reasoning behind it, at least. So to commit files, we use git commit. So git commit is saying, hey, Git, I did something. There are some staged changes that I queued up with Git Add that I want you to take a snapshot of. So if I do git commit, it will take me to this screen. This is my editor, and what editor you use can be configured. On my computer, it's Vim. If you Google, if you Google like git set default editor or something like that, you can have it open in whatever editor you choose. So I know like Dino, my mentee, he uses VS Code, so it opens up in VS Code. But regardless, this is a screen where we can add some notes. So I'm just going to say, and so at the top, we can have some short summary and then maybe some details here. So when I close the file, we get this message say, hey, here's a commit, and we got one file changed. Now if we do git status, nothing to commit. Everything, the file is still there. And note that nothing we did here changed the file. We're just telling Git to start caring about the file. And the rule of thumb is we want to commit as often as possible. Basically, anytime we have some change that works, we want to make a commit. And we'll talk about why going forward, but basically, Git lets you examine all the changes between every commit. So the more commits that you have, the more useful fine-grained information you have. Also, remember that by default, Git only commits the files you ran add on. That's why when we did Git status, it had changes to be committed, right? So if you don't do Git add first, then it won't commit those files. Except if the whole like staging thing before you run git commit seems confusing or weird, and you don't want to have that extra step and you just want it to always just commit directly, or just commit everything that's changed, you can add the -a. So git commit -a will change or will commit every tracked file that has already been changed. If I add a new file, like if I add some you know, if I add some new file here and I try to do, so here we see get or test.txt is untracked, but if I do git commit, this is going to fail because test.txt, we have not been told to add it. It is not tracked. Oh, also, the command was wrong, but so it says nothing added to commit, but untracked files present. So we need to do git add test.txt and then git commit. So that is that. And also, so the rule of thumb, or not rule of thumb, a common pattern is that the longer a project goes on, or maybe the later at night it is, your commit messages gradually get less and less useful. The little messages we attach can get just kind of useless and just saying, hey, some changes. Try to resist that habit because these commit messages that we added, these are the labels for each commit. And if you're looking back at the history of your project, if everyone just says made some changes, it's not really saying what the changes are, and it can be a little difficult to navigate. Any questions about commits? Or anything else for that matter?
And also, please feel free to put your questions in the chat if any questions do pop up as Perry's speaking.
All right.
All right, let's do it.
So that's the basics of the Git workflow. And so we repeat. So let's just go through another quick example. So, and I'll show a couple other Git features as we go. So let's make some changes to my file here. And hold on. Yeah. So let's make some changes to my file. So we'll just add a paragraph here.
All right, Perry, we do have one question.
Still not clear on the A tag with git commit. That is a good question. So the dash A is, well, here. Actually, this is a good chance to demo that. So right now, in addition to saving your changes in Isaiah, so right now, so no, actually, GitHub sort of ties in to Git and stuff like that, but you don't need to be using GitHub to use Git. So right now, like we're just using Git, like it is just on my computer. I don't need to do anything. I don't need to interact with GitHub or anything like that. Now, if we were connected to GitHub, like if this was a project that we have set up to track with GitHub, then after we commit, if we do Git push, it will send the files to GitHub, and that's how it will push them from your computer to the internet. But no, we only need to do all these things locally. So Cate, so if I do Git status right now, so I made some changes to index.html, and if I do the Git Diff command, so Git Diff so Git status says, hey, this file changed. If I do Git Diff, it'll show what the change was. So we can see that we got a plus sign, and normally this would be green, but on my computer it's gray because of my color scheme. But it says, hey, this thing was added, right? Now normally, if I do Git commit on my own, then it says, hey, no changes added to commit. Nothing changed here. It didn't actually do the commit. So we need to explicitly tell Git that we want to add certain files, right? The reason being, like, let's say we make a change in 2 different files, right? Maybe we only want to commit one, right? So if we do Git Add, so by doing Git Add, we're saying which file we want to change, or which file we want to commit. So now says, index.html is to be committed. So by doing the -a tag, we are skipping that step. So we still have some changes in test.txt. Specifically, I just added some other text or something. If we do Git commit -a, it's saying, all right, any modified file in here, all of the modified files, go ahead and commit them all without me needing to explicitly add them. So I hope that kind of a long-winded answer, but basically, if you do the -a, you don't need to run Git Add first.
Got it. That's very clear.
Great. So Git Diff, as you noticed, it shows all the changes in the tracked files since the last commit. So I like to run it every time or before every commit that I do, so I can see exactly what changed. I do this because sometimes in the process of development and debugging, it's entirely possible that certain expletives may make their way into my code while I'm debugging or something. And it's a good idea to kind of see all the changes that you've made and make sure that you're not about to send something to your manager with swear words in it. This is a true story. So anyways, so in summary, there is Git Init that creates the repo. Git Status is how you view the list of the modified files. Git Diff is how you see what the modifications are. Git Add lets you stage the file for commit, say, hey, when I run commit, you should make a note of this change or the changes in this file. And then Git Commit is how you take a snapshot of those staged files. Any questions about this?
No questions? All right. It's all yours, Perry.
Right. So let's move on to part 2. So useful things. So these are not the only useful things that Git can do, but these are the ones that we have time to talk about today. And they are what I think are some of the most important things about Git. These are all things that, again, you don't need to be interacting with GitHub if you don't want to. This is just if you're on your own on your computer. So the first thing is you can view the history of your project. So if I do git log right now, I can see a list of all the previous commits that I made. So, okay, the last thing I did was I added some gibberish to my text file, added my name to index.html. I added this test.txt. If I press the down arrows, I can see my first commit. So I can see all the changes I made and when. Also, now everyone has my email. Use it wisely. So let's talk a little bit more about Git Diff. So Git Diff by default will show you the difference between or it will show you any changes you made in your files since your last commit. But we can also see the difference between commits. So when we do git log, these numbers at the top of every commit, this is called a commit hash. It's basically an ID. And so if we copy paste these into commands, we can use that to navigate around. So for example, if I want to see everything that changed between here and here, like everything that changed between my first commit and the thing where I added my name, then I can do git diff, and then I copy this one and this one. So show me all the changes between one and the other. Actually, wait, I got the order backwards. It should be first. So the first one is the earlier one. So git diff between here and here. And I can see, oh, in that commit, I added my name to this file and I added hi to this test.txt file. So I can see, and this applies if you have a project that's been going on for years, I can see like any changes that were made over any period of time. So I once, I worked at a company for a few years and I once just did a git diff to see all the changes that were made since I started working at the company, for example, which is just kind of neat. That doesn't actually serve any real purpose, but that's neat. Or if you're trying to figure out why the behavior of something has changed, it's useful to be able to see what has changed in this file, So, yeah. Oh, and also, right. So if I want to see everything that has changed since a certain point, I can just do git diff, whoops, and then one particular hash. So if I say everything that has happened since, this one is the very beginning, right? So what are all the changes that I made since I added the initial file? So you git diff, and I can see, okay, I added hi, my name is, I added hi, and some gibberish to that file. So any questions about git diff? All right.
Go for it.
Sweet. So now let's talk about, so this is where we get more interesting. So let's talk about the git checkout command. Git checkout is basically how we can time travel within Git. And it's saying, hey, Git, let me check out this code. And it shows you, it resets the code to whatever it was at that particular commit. So for example, so I've got this log and here's my file and here's how it currently is. I say, hi, my name is Perry Cate. Hello, Emergent Works. So if I do git log, let's say I want to go back to how it was in the beginning. So I'm going to copy this commit hash. If I do git checkout this commit, and it gives me some long warning, blah, blah, or not warning, but just some detailed information. It's advice. So now if I do git log, notice that this is the only commit in there. We effectively went back in time. All the other changes haven't happened yet. And now if I look at the code, that thing that I added is, Just for the record, I'm not currently live on Twitch.
Oh, yes, sorry. Not currently. I'll change that.
I did give this talk last night on Twitch just as a practice thing. But anyways, but notice that the test.txt file has disappeared. It no longer exists. And the thing that I added with my name, it's all gone. I went back in time. This is really useful when you're debugging code, because if, let's say you have a bug or something unexpected is happening, I can go back in time to last week and see if it was behaving strangely then. And, or was the code okay last month? Is this something that I introduced in my changes in the last month? If so, I can use Git Diff. If the code was misbehaving a month ago and I just didn't realize it, well, now I know I can look at, some of the older changes. I can look at the code as it was then without needing to waste time looking at the things I've done recently. So that is Git Checkout. Oh, and by the way, so it was talking about head. It was saying you're in a attached, or head is now at this thing. If I do Git status, it should say head attached at this thing. What does that mean? Head is basically the you are here in a repository's history. So we can view a repository as a list of commits, like a timeline. And Git checkout is moving our head, our you are here, to some other commit other than the most recent one. So this is our project, right? And each one of these bubbles is a commit. By default, we're on our main branch over here. And so by default, our head is always at the end. But when I do Git checkout, it moved me to the back. So we're undoing all of the changes that have happened since then. And I can move around and so forth. So to go forward in time, so it's not like we lost those things permanently, right? So to go back to where we were, we can just do Git checkout main. Main is the name of our default branch. We'll talk about branches in a moment, but if we do checkout main, it's basically give me the most recent commit that I have made in this branch, basically. So, oh, by the way, talking about default branch, and again, we'll talk about the branches and what that means later, but basically it's a pointer that means like the most recent changes, or you can think of it that way. A quick note on that. So these days, the default branch name is usually main, especially like if you're using GitHub or GitLab or Bitbucket or something like that. So usually your default branch name is main. But before, that's a fairly recent change. It used to be master by default. People started using main instead of master because of the connotations of master, and it's just kind of weird. Like, why do we need to call this master? So people mostly use main, but if you are Googling instructions or something and it tells you to use master, that's why. Master and main can mean the same thing. If I try to do Git checkout master, then Git's going to say, I don't know what you're talking about in my project. If you're working in an older project or something else that somebody else created, maybe you run Git checkout main and get an error. And if that's the case, try master. So just a quick note on that. Any questions about time traveling with Git?
Good stuff, man. Good stuff.
All right. So that is how we can view the history of Git, or view the history of our code, rather. Next, Git can let you reset your code to working versions. This is an absolute lifesaver and is perhaps the most useful thing about using Git, on your own at least. So let's say we have some changes. So, you ever work on a code base and your cat just kind of sits on your keyboard or something? And yes, I could do Control Z right now and fix it, but maybe, you know what? Maybe I accidentally, I make these changes and then my computer crashes, or I accidentally close it. And so now I have to reopen it, and Control Z will not help me here. I cannot undo my changes. I'm oops, I'm beyond hope. My code is completely borked. Nope, not the case. We're using Git. And so with Git, so we haven't committed this change or anything. So Git Checkout will save us actually. So if let's get our bearings here. So if we do, so Git Status, let me zoom in a little bit more. Git Status, we'll zoom out. So we're on branch main and, oh, hey, look, we have some changes here. I can actually view those changes exactly. So if I do Git Diff, right? Okay, so we removed all this working code and replaced it with this garbage. Now, if I wanted, I could just like copy paste these things, you know, I could just copy paste the code, but maybe it's a lot of changes, you know. Git commit will actually say, or Git checkout rather, will save us. We can reset the file to its last commit with dash dash. So for example, so the file name is index.html. If I do git checkout dash dash index, then now I'll do git status, nothing to commit. What does that mean? And look, my code has been restored to the last commit that I made. So this is another big reason that I say to commit often. Your commits are basically checkpoints. And so like in a video game or something like that. So if you want to commit as often as you can so that you can go back to the last working version that you had. And so all that gibberish that I did just got completely undone. Yay. There are other ways of resetting. So git reset dash dash hard will accomplish the same thing. But if you pass in commit IDs, it can cause problems. So if you are Googling something, git reset dash dash hard exists, but git checkout dash dash and then the file name is usually what you want to do. Any questions about that, about how we can fix our code and go back to the most recent commit? Also, pace-wise, too fast, too slow, just about right. I'm really just giving that. I'm really just saying that so I have an excuse to take a bite of my banana while I wait. All right.
It's all good, man. Brandon says still good for me.
Great. So that's how we can undo changes that, you know, like accidental stuff, or maybe we're debugging something that gets out of hand or something. That's how we can go back to the last known commit. But what if we make a mistake in our code and we committed it? That's git revert. So what this does is it will undo all of the changes that we made in commit. And this actually creates a new commit in the process, undoing the old one. And this works regardless of how old that commit is, even if it's something that you did like months ago. So let's demo that. So as I remember, we have this test.txt file, right? And I think, yeah, I added some random stuff here. I could just delete them from the file directly, but again, let's pretend, you know, if this is a code base we're working on, maybe this is hundreds of lines and I only want to delete some of the lines, you know? Well, I can see in the log, I added some gibberish to the text file up here. So, and that's already committed. So if I do git checkout dash dash, it's not going to change anything. But if I copy this commit hash, I can do git revert that commit. And it populates a commit message for me saying, hey, you can revert that. And now if I do git log, we can see here's the commit where I did that. And now I have another commit reverting it. And if I look, as you can see, it has undone the change that I did in this file. So yeah, that's git revert. Any questions about that and how we can undo committed or uncommitted changes? Note that in that case, I was undoing the most recent commit, but we can actually undo things from like months ago if we want. It's pretty powerful. All right. So next, the last useful thing, this isn't, Git can do many useful things, but last one in this section, is it gives you a way to safely test new ideas. Now, I have a confession to make. I may have told a little white lie earlier in the presentation. I mentioned that you can view Git as like a linear history where, okay, it's one commit after another. In reality, it's not just one line, like one timeline. You can basically have alternate universes and alternate timelines. So, and these are called branches. So, and in this case, each branch has, well, yeah, you can have alternate timelines where maybe we did different things to the code base and we can switch between these, and these are called branches. So to list between all of the branches, we can do, or to list all of the branches, we do git branch -l. Also, I say these slides are actually, I've given this talk before, and clearly I forgot to change master to main here because last time I gave the talk, it was before they did that. But main is just the default branch, or master if it's an older project. So if I do git branch L, well, there's main, and I don't have any other branches. I've just been working on one branch so far. To switch between branches, we do, once again, git checkout. Git checkout is pretty much the universal way of switching between states of the code base. And so if we want to create a branch, then we can do git checkout -b, as in new branch. So one note, so let's say I have, let's say I want to create a new branch, and we'll call it new branch. New branch doesn't exist yet, so if I try and switch to it, it's going to complain and say, hey, this doesn't match anything. This, I don't know what you're talking about. So that's why we do this is a new branch, so we do git checkout -b. Let's call it, yeah, whatever. This can be any name that you want. I'm calling it new branch, but it can be anything, you know. I could name it Harry if I wanted. So now if we do git branch L, we can see, so there's main and there's new branch, and new branch is the one that we're currently on. Now, if we do git log, new branch has all the same commits. We haven't changed our code. Our code looks the same. We haven't done anything yet. But any commits that we now make, if we do git status, we can see we're on the branch that I'm calling new branch. So any commits that we make will go on new branch and not the old branch, not main. So let's make a change actually. So what should we do here? So something like that, right? So we made some change, right? And the change itself doesn't really matter here. But I deleted the thing with my name and I added a list here, right? So, oh, also, wait, this should, not that it really matters, but. Yeah. Anyway, so we add some code here, right? And again, the change itself doesn't really matter. So let's do git, well, first I always do git status. So we're still on new branch and we can see we modified our file. And here we can see we removed the hi, my name is Perry Cate and replaced it with this stuff. So let's commit this. And actually, let's introduce another useful thing. So remember how every time that I've run git commit so far, it prompts me for like, it puts me in an editor and asks me to write some message out. If my message is really short and I don't want to have to go into an editor, or maybe I don't have my preferred editor configured or something like that, I can add the -m tag and then put in quotes some message. So so here's my commit message, and this would normally be like the top line. And that does everything sort of in one step. So we do git log, we can see, and we have our new commit. And note some of the labels here. So we're on new branch, and new branch has this. But if we do git checkout main, now we're on branch main, and those changes are not present. So main is the old stuff, and then new branch has that list of random things. So this is what our history looks like. Main is back here and new branch is here. Any questions about this or why this might be useful? All right. So let's add on this a little bit more. So we can also, so we have new branch, which has some changes, and we can actually continue to make changes on main. So right now, if we do git status, we're still on branch main. So maybe I'll make some other change. Right? So I add some change here, and the change doesn't really matter, but if I do git diff, there it is, and I'm going to commit it. So commit dash A, so I can skip the adding everything. I just want to, or I can skip the git add step. I'm just commit that, and we'll specify the message here. So now, if I do git log from main, I can see, okay, I have my new commit here. And if I check out the other branch and git log, I have now the code has this list of things, but not that Twitch stuff. And that commit doesn't exist. We basically have two alternate histories where we have one thing here and one thing here. This is really useful for companies for a couple of reasons. One, if you just have some idea you want to try out, like what happens if I do this, but you don't want to mess up your main code, you can do a separate branch and do whatever changes you want. You can screw everything up and it won't affect anything in main or whatever your main branch is. Another really common thing is companies will have like their main branch, which is like what gets released, but people will do their work and everyone has their own private developed branches, and then they merge it into main once their features are ready, for example. Say again? Say again?
Oh, I'm sorry. Not you, man. Sorry.
You're good. So let's say that we made some changes in main and we made some changes in new branch, but actually, you're good, Eli. So let's say that I like both of these changes and I've decided I want them all in the same branch again. So this brings us to git merge. So git merge takes all the change, so you specify the branch and it takes all the commits in that branch and merges it into whatever branch you're currently on. It doesn't delete that old branch. You can keep working in it if you want, but it just takes any commits in there and merges it into the one that you're currently on. So Git can often do this automatically, but other times, so let's say that I made two changes to index.html, but like one was at the top and one was at the bottom, and I'm not changing the same lines on either of them. If that's the case, then when I do git merge, Git will say, oh, well, okay, you added some stuff here and moved some stuff here, but they're not in conflict. I'll just put them together for you, and it just works automatically. In my case, my file is kind of small, and I did changes in the exact same place. So on one thing, I like deleted a line and I added different content to the same line here, and Git's not really going to know what to do. So let's see, what branch are we on? Git status. So we're on new branch. So let's go to main, and I want to merge all the new branch commits into main. So this is what the code looks like. I've got my plug, and I didn't make any changes in the test file. So if I do git merge new branch, so it tried to automatically merge them, and sometimes it just works and you're done. In my case, it's saying, hey, there was a merge conflict. That means you change the same place in the same file in two different timelines, and I don't know what to do. Like, do you want to combine these? Do you want one to overwrite the other? I don't know. So note that it added these little markers here saying, okay, here's what your current change is. Here's one version of it. Here's the other. Now you figure out what you want to do. And VS Code has some nice buttons to automatically like accept them or whatever, but I like kind of changing them manually personally. So let's see what I want to do. So we'll keep the hi, my name is Perry Cate, but let's move this second line down below here. So I might need to make some interventions. I might change things. And then when I'm done, I can remove these markers here. And I edit the file until it looks what I want the merged thing to look like. I want to combine all of these changes. And so now, so if I do git status, it still says, hey, this is unmerged. So I have the file how I want it to look like. Git is still not sure. Git needs to be told explicitly, hey, this is what I want it to look like. So now I will git add index.html. I'm basically just marking it as a commit. So, and merge branch, new branch. So it will pre-populate something. So notice now in our Git history, we have all the stuff that was in here to begin with. We have that change that we took from new branch, the list of things I'll never do. We have the Twitch info stuff, and it made a separate commit for merging the two of them. And now if we look, our code base has the merged version here. So, and so basically we took our two timelines and merged them. This slide is out of place, but whatever. So in summary, we have git log, which lets us view all of the commits that we've made on our current branch. Git diff will show us the differences between any commit. So if we give two different things, I can actually, if I do git, I can do git diff with branch names as well, I'm pretty sure. So if I do git diff main, or let's see, new branch main, I can see all the differences between that new branch and main. So main has these merged things. It has the hi, my name is, and I stream while I code. And new branch does not. And I can just see that with git diff. And git checkout lets us move head around and see, let's change the code in my code base to this particular point in time, or this particular reality, this branch. Git revert lets us undo old commits. Git branch lets us create a separate history, an alternate timeline. And git merge lets us combine those branches into one. Anybody have any questions about all of this? Anything?
Good to go. Oh, Nikita says no. I guess we're good to go.
All right. So that is the most important things about Git, in my opinion. And note that this is all just on your computer. This is you on your own working on your passion project or something like that. However, Git can be used for much more than just that. Git can also be used for collaborating with others. Words are very hard right now. So since we have a little bit of extra time, let's talk about it. And some of the slides might be a little bit out of date because I didn't think we'd get this far, so I didn't update them, but it should work fine. So Git is, so if we think back to that blurb at the very beginning about Git is a distributed version control system, blah, 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 from the official website. It actually does matter. So Git is distributed, meaning that if I'm working with a team, my repo is on my computer. And if I'm working with Dino, then he has his own repo on his computer. And so if I can be on an airplane or something, or just not have internet access, and I'm still running all these Git commands, it's all on my computer and mine alone. Nobody else can see them until we merge them together. So let's talk about GitHub. So GitHub is not the same as Git, but everyone always gets them confused. but it's a third-party website that hosts Git repositories. And it has some very nice tools for like code reviewing and stuff like that. So when I'm using GitHub, I have a copy of the repository on my computer, and GitHub has a copy of the repository on GitHub. Isaiah, thank you for coming. I hope that you found this useful. And if you have any questions, feel free to hit me up on Slack or anything like that.
Have a safe weekend too, man. Thank you for joining us.
So what was I saying? Yeah, so GitHub hosts or has copies of Git repositories. It's not the only thing. There are alternatives to GitHub. There's this thing called GitLab. There's Bitbucket. And various companies use different tools depending on reasons that probably involve money. But they're all kind of used the same. GitHub is by far the most popular though. So we'll be talking about it. Also some new terms. So remote repository is the repository on someone else's computer. So again, in this case, when we're using GitHub, GitHub is the remote repository. And it is a remote repository to me and anyone else on my team. It is like the central place that I'm sending my changes to, and I can get changes from that other people made from GitHub. So jokes on you, this section isn't about collaboration, it's about GitHub. So to set up a repo for collaboration, so let's say I'm on GitHub, and if we click the plus sign in the top corner, there's a thing for new repository. And the repository exists on my computer, but we're adding a repository on GitHub. So we can give a name. There's an option that says like, do you want to initialize this repository? Don't, we already have it on our computer. So it'll give us some quick setup. It'll give us a link to copy and some commands to run. So if these, we can just copy paste them really, but we're remote add origin. So this is telling our repository on our computer, hey, there's this link on GitHub that I want you to be able to send files to. So now when we actually, let's do that. Let's just do it. So I'm gonna, oh, I'm not signed in. Oh, hang on. You can see my other email. Oh, and I don't have my phone on me. All right, well, we're not gonna worry about it too much. We're running low on time anyway, so we'll just rely on screenshots. So
all good.
Yeah. So in this screenshots from 2018 or whenever, so I added some repo and I do git push origin master, just copying the commands. And again, these are older things, so note that it's master instead of main. These days it would be main, so git push u origin main. And at that point, you should see it appear in GitHub. You should see, what's U? Good question. U stands for upstream. Basically, so when we are pushing things to GitHub, typically I have a branch on my repo and there's a branch on GitHub, and they're both called main, right? But the first time that we push, there is no repo, there is no main branch, there is nothing corresponding to that. So by adding the -u, it's telling, hey, it's effectively forcing it to say not forcing, that's not the right word. It's basically saying, hey, if the branch that I'm on or the repository that I'm in doesn't exist in GitHub, you should create it. So you actually only need to include the -u the first time. After that, it should work. If you create a new branch, then it may say like there's no corresponding branch in the remote, and then you add the -u. But basically, you only need to add -u the first time, and it's saying, hey, if this branch that I'm on, main in this case, doesn't exist in GitHub, create it. Good question. So there's only two commands that you really need to know for interacting with GitHub. So git pull says it will tell Git, hey, go to GitHub and take any changes in GitHub that aren't on my computer and pull it down here. So we pull, And similarly, when I make some changes and I will commit some stuff, those commits are present in my branch, but not necessarily in GitHub. So when I do Git push, I'm saying, hey, GitHub, I made some changes that you should be aware of, and I'm sending them there. So now after I do Git push, they're on GitHub. If my computer crashes or something, there's a backup copy. It's on the internet now. Or my teammates, after I do Git push, my teammates can do Git pull, and GitHub will send the changes to them. Any questions about Git pull and Git push? Also, as a general rule, you always want to pull before you push. So I like to pull before I start working on the code. You know, if it's the beginning of the day, maybe one of my coworkers pushed some changes overnight. I want to do Git pull to make sure that I'm up to date, and then I push after that, after I do any commits. All right, not seeing any questions. So yeah, so one last thing. So by default on GitHub, when I create the repository, it's just for me. But the most useful thing is collaborating with others. So if you go into, there's a settings tab, and you can click on collaborators, and you can add other people's emails to give them access in GitHub. And let's say that there's a project in GitHub that already exists. We can clone it with git clone, and this will be a great thing to end on. So if I have some project here, right? And excuse the dark theme. So it looks a little different from the screenshots because I think the dark theme is cool, but it doesn't really matter. Regardless, I can click on code and then clone. So it gives me a link, and I can copy it. So I can create a folder that I want things to be added in. So if I do git clone and then the link, it downloads that. So if I can now do cd p2ping being the name of the folder here, the name of the repo rather. So now this is my project, and the contents of the project doesn't really matter, but when I do git clone, I'm getting the full history of this. So I can see all the changes that I've ever made to this particular project and all the notes that I've taken. If I want to see what my code looked like on October 12th, you know, bam. Now I can go back to, this is an older repo, so there is no main branch, it's master. But whatever. Anyways, and now I've cloned this repository, and now if I make any changes, if I make any commits, I can do git push to send them up to GitHub. And there's no more configuration necessary. So yeah. So in summary, you can set up an empty GitHub or GitLab or Bitbucket repo on some website. It'll give you commands for getting your code up there initially. And then you can give your partner collaboration access. And then your partner can use git clone to get their copy of the repo, and it's already set up and ready for them to use. And always pull before you push. Pull takes the changes from GitHub and merges them onto your repo. Push takes the things on your repo and sends them to GitHub. So, big summary here. Git is a very useful tool that is not the same as GitHub. It is a tool that you can use even on your own, even if you're not working with others, just using on your computer. You can commit, or you can change your history or look at your history. You should commit as early as you can and as often as you can. History is a tree. You can have alternate realities, and everything is reversible. So Git, like I said, is very powerful. There are some other topics that I will briefly just mention. We're not going to go into it. I think we're at the hour mark, so this is a good time to stop. But just a couple of things you can Google later.
We can go about another 10, 15 minutes if you need it.
No, I don't think so. I don't actually have slides prepared. I'm not actually prepared for these. I just want to drop a couple of terms so that you can Google things later. Git stash is, remember Git checkout lets us delete the change, or like if we do Git checkout dash dash, it'll delete all the changes. If we do Git stash will hide them, but then we can pull them out later and reuse them if we want. Rebase is a way for us to sort of combine old commits and tidy up our history. And Git reflog. We definitely don't have time to talk about reflog, but basically every commit, you can think of just like your commits are a timeline in Git. Git also has a hidden timeline called reflog, and that is the history of all the commands that you have ever run in Git. So in other words, if you are not sure about a commit that you're, or about a command that you're running or something weird happens to your repository and you're not sure what, Git reflog, just Google like Git reflog reverse changes or something. Because there's a lot you can do with it, but basically you can go back in time and undo any command that you ran in Git. Super powerful. And maybe we have a more, maybe we have a part 2 at some point where I can go into some of the advanced things, but
yeah, that actually sounds like a great idea.
Yeah. So that's it. This is the presentation. I'll leave the big summary up there. If anybody has any final questions, I'll take them now. Confused about reflog because it was thought it was pronounced reflog. Honestly, I'm pretty sure it's reflog, but I'm going to start calling it reflog in my mind because I just like it. But no, it's definitely reflog. That is funny. Cool. Well, Eli and or Army or may have things they want to talk about. But just as a reminder, so I'm Perry. I hope you all enjoyed this talk. I am actually going to send out a survey just to see. I want to know what y'all thought about this. I'm always trying to improve with my presentation skills and things like that. So I'd love to know what you thought. And you're not obligated to do it, of course, but I would love to get any feedback. Oh, also, yes, thank you, Eli. So here is a cheat sheet. I didn't make this cheat sheet. It's just some website, but it has a summary of all the commands we learned today and many more. You can really just look at the first page or so, and that'll be everything we talked about today. But those are the most important ones. So, and yes, I stream Monday, Wednesday, Friday at 6:30 Pacific, 9:30 Eastern. If anybody wants to watch over my shoulder while I live code, or I also do leak code questions, it's a good time. So if you are interested, that's twitch.tv/gravity. And I will send out a survey as soon as it exists. How do I stop presenting? I'm done.
Okay, let me see if, there we go. So screen, yeah, I'm still disabled. All right, can't tell. Am I back on or is Perry on? Host disabled. Thanks for your time. Man, thanks a lot for coming by, Brandon. All right. Okay, bet. All right, so thank you everybody for joining us today. This was actually an amazing workshop, from the tips to the tricks to everything in between. Thank you, Perry Cate, one more time for your time and for your expertise. We really do appreciate it. And we can definitely talk about creating a round 2, because I think that will definitely add to the value of the presentation. So, hey, man, thank you for locking in with us. World EW community, thank you. Please follow us at Emergent Works _ on all social platforms. Feel free to reach out to Perry. His cheat sheet is in the chat. And if you're watching this on YouTube, just hit us up. You can actually reach out to me directly at eli@emergentworks.org. And yeah, connect with us. See you guys soon.